Thank you very much, Zach. All right, I wanted to do a quick reality check so we know what's coming up in terms of assignments. So everyone's on the same page. Here's our syllabus. Let me share my screen once we get to it here. All right, you guys can all see the syllabus? Yes?
Yes.
Thank you. Thank you, Ashley, for the thumbs up too. So we are continuing our good measurement lecture. We're going to wrap this up today. Everyone has a research topic that they've submitted. Everybody's on the same page, so we are good with that. Next week, we are going to be discussing surveys and observations, and your article critique number 2 is due by the end of the week. So by Friday, you need to submit your article critique 2. The following week, we are going to be doing the exam. And as you guys may or may not remember, there's been a schedule change. So week 6 is still the exam. Week 7 is going to be the sampling lecture. We're going to do that week 7. And week 8 is our qualitative research experiment. So be on the lookout for additional information for that when it comes out. But just so we're all on the same page, article critique will be due next week. And then the following week will be the exam. Okay, so let's stop this one. Any questions about the schedule? I don't know if it's like a Friday, just early morning. No one really wants to be seen.
What day is the exam on? Would it be on the Tuesday or Friday?
That is an excellent question, one that I had not considered. I guess in my head all along, I was thinking Tuesday. But do people have a strong opinion between Tuesday and Friday? No opinions? Let's plan on doing it Tuesday and not having class on Friday. This way we make it fair with the other section. The other section just is taking the exam. That's all they're doing that week. So then we'll do the exam on Tuesday, and then Friday, that'll be a little time off for you guys. How does that sound?
Sounds good.
Okay. All right. If you have any strong feelings that you want to communicate just one-on-one, please let me know. Shoot me an email, and then we'll go from there. Okay, so let's pull up our lecture, which somehow is not listed as an option here. Let's see. Here it is. Share. That's the most bizarre thing. I can't seem to. And I will warn you guys already, my dogs are being crazy today. I don't know if it's the snow that's like getting out of them. But they're just both. Okay, here we go. All right. No, thank you. All right. Can you guys see it?
Yeah.
Do you see it on the big screen or do you see the little notes?
Just the big screen.
Okay, perfect. All right, so we were discussing how to find good measurement and how to assess good measurement, specifically because if you don't have good measurement, then really whatever you're measuring is not going to be super accurate. So please help me remember where we were. I want to say we had discussed all of this and we had talked about the different types of reliabilities, right? We had talked about all of this, or no?
Yeah.
Had we gone into scatter plots?
No.
Okay, so that's where we will obviously be starting from. So when we're looking at reliability, just a quick reminder, reliability is how consistent are your results. So at time 1 and time 2, are your results similar? Or You could have reliability in terms of these are similar content scales. It's a scale of depression. This is another scale of depression. They should be consistent with one another, meaning if you are identified as depressed on one, you should also be identified depressed on the other one. So you want concordance of scores or convergence of scores. That shows high reliability. The way that you can calculate reliability is through doing a correlation, but you can also use a scatter plot to evaluate how similar they are. So this is the measurements for head circumference for certain children at time 1 and time 2. What you can see is that they are very consistent over time. So for instance, Taylor at time 1 was at like 50, and time 2, oh my word, this dog. Time 2, the measurement was 52. Okay, that's pretty close together. You can see here, Kendra, very similar, 61 and 59, Mateo, 65 and 64, and Kurt at 75 and 80. So if you are plotting these dots, right, you can find, let me have my little pointer so you can see a bit better. You can then create a line of best fit, which goes right through here, right? And so based on what we've discussed in terms of slope and its relationship with correlation, what are your thoughts on how correlated these two measurements are?
They're pretty correlated
Okay, and in what way did you figure that out, Ada?
because they're following like a pretty close to the slope.
Okay, and what would you say is the slope of this line?
Like number or like positive?
Well, so either one.
I feel like it's like close to a 1, maybe.
You're absolutely right. So I think the slope is approaching 1, meaning as one variable increases by 1, the other variable increases by almost 1. So this is almost a perfectly, slope of 1.0, which would mean an absolute positive correlation. Okay. So these are highly correlated. So the correlation score would be very close to 1. Again, they range between -1 to 1. Closer you are to either ones, whether it's positive or negative, the more strongly correlated they are. And in this term, we would say the more closely reliable is our measurement, because our measurement has remained the same over time. Okay, that shows high levels of reliability. Okay. We can look at this again. This is another form of reliability. This one is inter-rater agreement. So if, let's say Mara and I decided to go to the grocery store and take a measurement of how often people followed the arrows down the aisles, in the grocery stores, we could each be standing and we'd be taking measurement. Yes, they followed. No, they didn't follow, and so on and so forth. And so at the end of our period of time where we're doing the experiment, we would compare our results and we would determine how closely we rated them the same way, right? So that's inter-rater reliability, meaning is my rating reliable or in line with Mara's rating? So these are examples for exactly that. So this is Matt and Mark. They rated children in terms of how happy they were, I think. Yeah, how happy they were in the sample. And based on this, you can see that this is almost, again, a perfect slope, a perfect slope of 1, that is, which shows strong correlation. So these two raters, Matt and Mark, were highly reliable. They had strong inter-rater reliability. Now, if you look over here between Peter and Mark, though, there's a lot more variability that happens between their scores. So for instance, you can see here, Mark rated this particular kid as a 6, while Peter rated him as a 2. So that is a strong difference. It's not close aligned. So when you look at it in terms of the line of best fit, this is approaching a slope almost of 0, which shows poor reliability or almost no correlation. Okay. What might be a reason why you would get such different scores from raters? What do we think?
There could be like not specific rules or goals that were set up in place before the experiment.
Okay. Which meant that one person rated it one way based on their own maybe definition and someone else on a different one. Yeah. It could be that there's some environmental factors that made it that one observer didn't have maybe as clear of a view, or, there's a lot of hypotheses that can come in, but it does show discrepancy in the ratings. So how much stock would you give in any findings from this study? Specifically here, Mark and Peter.
I would give it less stock than like the other study,
Why is that?
because we don't like know why there's such a difference, because they're the same person, so there must be some flaw in one of their observations.
Absolutely. And when you look at this, whose rating do you trust more? Who's accurate here? When you're going to have that big of a difference, and one says 6, the other one says 2, or one says 7, the other one says 2. That's a lot of variability. So you cannot trust the data in as significant of a way when you have that much discrepancy. It's not reliable. Okay. So again, as you look through, whenever you have data points, you use the coefficient R to evaluate reliability. You're looking again at a correlational value. You can do that for test retest, meaning I took the test on this date, took it again on this date. How similar are my scores? Provided though that you didn't insert an intervention, okay? It is a difference when you do test retest. It is not the same as doing a pre and post test. Why is that?
Because a test retest, like nothing has changed, but if you have something that you changed in the middle, then the variables will be different.
Absolutely. So with a pre and post test, you're really evaluating the strength or effectiveness of the intervention, whatever you're putting in the middle. A therapy class, maybe you're teaching a child a certain behavior, maybe you're, like a pretest for this class, then I introduce material for the class. So you are evaluating how effective is the intervention or the teaching, right? That's what's standing in the middle. You okay? Oh, he's down there. Yeah. Now, if you are doing something like a test retest, there is no intervention in the middle. What you are doing is simply seeing how strong or reliable of a tool that it is, because you're expecting the test to remain the same. So if I look at this data, sorry, my husband's trying to get our dog in. So if you look at this data, you can see the slope indicates how correlated they are. So the slope direction, whether it's positive this way or negative this way, just simply indicates, again, as one variable goes up, the other one goes up, or the other way around. As one variable goes up, the other one goes down, right? Like those are the options. The stronger they hang together or follow the line of best fit again, the stronger the correlation. When it's like this, we're not seeing a strong, reliable data. This is just a mixed bag of results, right? I can't make a meaningful prediction or correlation between the scores on a data set like that. Okay. There we go. Now, okay, we're looking at all these graphs. In a research paper, I would say you are probably never going to see that. It's far easier to understand if you're looking at it at a table. So this is an example of what an APA table would be on reporting the consistency and temporal reliability for a given scale. Specifically, this one is the satisfaction with life scale. So in order to evaluate how effective the scale is, what the researchers have done is they've gathered several studies that have utilized it and that have reported both its internal consistency and the test-retest reliability so that they can see what patterns are emerging. In other words, for instance, if I take this first one, Alfonso and Allison, they got a coefficient alpha of 0.89 and test-retest of 0.83. Maybe you think, wow, that's phenomenal. But in the absence of perspective, meaning comparing it to other studies, it's hard to have it known if it's just a fluke. So when you do this, you're able to see that there is actually a precedent, like it's consistent over time. So the coefficient alpha, that is reporting, or often known as Cronbach alpha, I think we talked about that last time, that is showing how internally consistent a test or survey is. We are looking for values of 0.7 or greater. That shows good internal consistency. And as you can see, it was highly consistent in all aspects or all previous studies that were published that utilize that scale. The test-retest score is a correlational value. Again, the closer you get to 1, the more highly correlated they are. You get to 0, no correlation. And then they included here how long there was between the test and the retest. So what can you learn from these values? What do we think? In other words, do you notice a difference in these tests, in these scores? Just by eyeballing it, the numbers are different, right? What is the range?
.33 or 0.33.
Okay, and how'd you do that, Ada?
Well, it goes from, oh wait, no, sorry. 0.34 because 50 to 0.50 to 0.84.
Okay, now that's a pretty big difference, right? So what might account for that? Someone else than Ada. She's been participating. We need other people to pipe up.
The time between a test and retest.
Okay, that's exactly right, Eliza. So there is going to be a difference between, again, whether you took it 2 weeks or a month apart versus 10 weeks or 4 years, right? In that amount of time, if you think a common example for that would be IQ. So you take a test maybe when you're 7, and then maybe one when you're 8, one when you're 10, once when you're 14. In that period of time between the test and retest, a lot happens in life, right? So more experience leads to greater learning, all of that. So that is often why there's going to be a discrepancy in scores. So just something to be mindful of. All right, validity of measurement. We need to always make sure that we are actually measuring what we think we're measuring. And in the process of doing so, if it is quite obvious what we're measuring, that's called face validity, is there an opportunity for respondents or participants to respond a certain way due to social desirability or faking bad, right? So we need to be mindful of that. So how does it look like, just looking at the question, does it look like a good measure, right? That's the first part. The criterion validity is, does it correlate with key behaviors? So key behaviors that I've identified as being present with that particular concept, are they part of it, right? Convergent validity and discriminant validity. So that's kind of a split way. So convergent validity would be, here's a scale again on depression. I expect that it will correlate well with another scale on depression, right? Okay, that is convergent. It converges together. Discriminant validity would be, here's a scale on depression, and I suspect there will be discriminant or opposing results if I give a scale on happiness, right? So in other words, if I'm highly depressed, I'm likely to have a very low score on overall life happiness or life satisfaction. But if I have, let's say, really low rates of depression, maybe I have a high rate of life satisfaction, right? So discriminant validity is looking at its opposing, or what you expect would be an opposing response on a different survey. Now, the relationship between reliability and validity is hugely important. It is important that a test be reliable in order for it to be significant. But if the test is not valid, it doesn't matter how reliable it is, okay? So validity kind of trumps it. And the example is the broken scale example. Now, a broken scale is incredibly reliable, meaning every time you step on it, you might get the exact same number, right? But is it an accurate measurement of your weight? Probably not, right? It's like stepping on a scale that has the permanent sticker for whatever weight you're hoping to see. While it's consistent, it's always the same, but it's not a valid measurement of your weight, okay? Does that make sense, guys? Hopefully. Yes. Thank you, Ashley, for the thumbs up. Okay. This is a chart that you will want to have handy and review for the exam. This details all the different types of validity and reliability. So first, you need to have a test that is internally valid, right? It is consistent and it hangs together. Next, you need to have construct validity, meaning if I am giving a test on depression, I'm not asking about favorite colors, right? That's not testing the construct. So there's two ways that you can assess the validity of a construct. First is through face validity. Does the questions actually seem, do they present like it fits the right construct? And content validity is the measure, does the measure you're using, does it contain all the parts that your theory says it contains? So if I'm doing a scale on depression and I only ask about how often do you cry and how often do you eat, that's forgetting a lot of the rest of the content of the specific, construct that is depression. For instance, inattention, for instance, maybe signs of anxiety, sleeplessness or change in sleep pattern, maybe anger, right? Like angry bursts, that's very common in males' expression of depression. So you would need to make sure that the entire content has been covered. Through this construct validity, there's three ways that you can empirically evaluate it. One is through criterion validity, meaning does your measure correlate with another relevant outcome, right? So a survey that tests exactly the same. And then the convergent and discriminant validity. So again, is your measure more associated with other measures that test something like it? And discriminant, do you expect opposing results for a construct that is very dissimilar? Okay. Oh, thanks, Eliza. Yep, page 134 in the book. So that is construct validity. Next, you have statistical validity, which you do doing math, right? So is it actually statistically significant? And then you need external validity as well, which often falls, you externally test it out with other measures. Now, as far as reliability, do you get consistent scores every time? Ways that you can assess that is through test retest or inter-rater reliability. And again, internal reliability is internally consistent. Okay, note right here, reliability is necessary but not sufficient for validity. Having a measure that is only reliable does not make it valid. Come on, there we go. All right. It's important to note that face validity and content validity are actually very subjective. So in my example with depression earlier, when I was talking about, does it just measure how often you cry or a change in eating habits? That is how I am subjectively defining depression. So whether it has good content validity is really up to the author and how they define their particular construct. Face validity is another huge subjective piece, meaning I think this is assessing depression because I asked, how many tissue boxes do you go through per week, right? Because I'm thinking that means you're crying. But there might be other reasons why that is, right? So in my mind, that may be a very face valid question, but that is subjective. So just important to recognize that. It's also important to recognize that with face validity, you are far more susceptible to socially desirable responses. Religiosity is a huge one. So if you ask somebody, you know, what faith do you align with, and then how often do you attend church services, or, you know, how connected do you feel to your church? It's more likely that somebody is going to over report that because it makes you feel better, like you're doing a good job within your faith, than underreporting, right? I suppose it could depend on the context of the conversation, but that's one that's usually, you know, linked to more social desirability. There are some though where it's very clear, like, I want to measure your head so I know what size hat to get you. That's face valid. There's less of a social desirability construct there. It just kind of is. So again, content validity, I just finished talking about that in terms of the example with depression, but with IQ, for instance, and I think we covered this last week or earlier this week, you can't say I'm evaluating IQ by just looking at brain scans when you're solving a puzzle, right? That is not the entirety of IQ. IQ has been defined multiple times in the literature, and it looks at all four of these aspects: reasoning, planning, memory, and problem solving. So you got to include all of that. Otherwise, you're not covering the entire content. All right. Now, again, for criterion validity, does your measure, does it correlate with key behaviors that you could see in somebody, that you can actually witness or observe? So this is someone's score on their sales ability, right? It's a sales test. And this is their actual sales volume in thousands of dollars, right? So here it is. You take a test, and then you compare it with a behavior, which is how much money did they make at the end of this? What do we notice here? No one? Okay, well, hopefully what you notice, go ahead, Ashley.
Well, it's positively correlated, isn't it?
It is. So the greater your score on the sales ability test, the more money you made. So if I'm a CEO wanting to hire salespeople, it seems like it would be a good idea for me to give out this test because this shows that it is highly correlated. So if I get somebody with a super high test score, I can predict or suspect that they will also produce quite a bit of income for the company, right? Okay, here's another example. So again, my outcome or the behavior that I'm measuring is the amount of sales, your sales volume, but this time I'm comparing it to IQ scores. So this would mean if somebody scored right around the 110, like Alex right here, where would I expect them to lie? And the problem with this is if you look at the chart, this dot shows that sales is maybe 30,000, 80,000. This is almost like 90,000. This is not a highly correlated relationship between the two. Because again, you can have very high IQ people that perform in the middle, and you can have very high producers that have lower IQ. So there is a smidge of a relationship, but definitely not as predictive as this relationship. So when you're looking at key behaviors that will line up with your test for this if for this behavior specifically, volume in sales, you're far more likely to have it tied to sales test rather than IQ. Right. Another way that we can look at key behaviors is to have it compared to known groups. So this is the BDI score, the Beck Depression Inventory, which looks at how depressed somebody is. And then you compare it based on those who are depressed versus not depressed. So that gives you a really clear indicator as to the effectiveness of your test. And then this categorization is based on a psychiatrist's judgment. So this would be a psychiatrist saying, I have 10 patients, 5 of them I've diagnosed with depression, 5 of them I've diagnosed with something else that's not depression. Give all 10 the BDI. You would predict that those who scored very high on the BDI, meaning they would qualify as depressed on the BDI, would be the ones that were also diagnosed with depression by the psychiatrist, right? That would actually line up. And then you could do something very similar again. You could break it down even further. So of those who are depressed, you can look at whether the psychiatrist rated them as mild, moderate, or severe levels of depression, and you should be seeing an increase in score accordingly. So that's another way that you can correlate it with the key behavior. So taking a scale and then seeing how it's exemplified in the person's life. All right, participation time. So looking at this chart, these are known groups. So it's groups of people, likely from different studies, that all completed the subjective well-being test. And those are their mean scores. So just quick stats reminder, N is the size of your sample, M, italicized, is your sample mean, and SD is your standard deviation. So out of this list, which group shows the highest level of subjective well-being? What do we think, gang? Oh boy, participation is rough today, guys. Participation is scored in this class. This is not a hard question. Which one has the highest mean? Which group?
Printing trade workers.
Okay, printing trade workers. Looks like somebody else was piping up here in the chat. Yes, thank you, Grace, also. So yes, how did you guys figure that out? You probably looked at this column, figured out which is the highest number, ding, 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 24.2, go across and you figure out it's printing trade workers. Now, which have the lowest subjective well-being? Which group?
Veterans Affairs Hospital.
Okay.
Inpatient.
Yes, Veterans Affairs Hospital inpatient. What is that? Those are our veterans who are injured or maybe mentally ill, staying in an inpatient hospital. They have the lowest. Gang, they have a lower score than male prison inmates. How sad is that? Okay. So when you're doing something like this, you can compare it, and how meaningful is that to go, well, what does that say about how veterans are being treated, maybe, or how they're feeling if their score is just barely below prison inmates? Like that's tough to look at. Being that I'm French Canadian, this is not surprising to me that they would score the second highest. I mean, I'm not a male, but I can see they're happy people. All right, so that is comparing it to known groups. All right. Convergent and divergent validity. And I don't know what's going on with my slide. I feel like it's all over the place there with my title, but this is again, Beck Depression Inventory. That is the score that people have on this instrument. as compared to the score that they received on this other scale of depression, which is the Center for Epidemiologic Studies depression scale. Okay. You can see that they converge pretty well together, especially those, if you look at the low scores, that's all clumped together. So you would expect, because those are two depression scales, that they would hang together pretty well. Now, the other hand, somebody might go, well, if you're significantly depressed, you are likely not in good physical health, meaning maybe you're not working out as much. Again, part of the depression symptoms is a change in eating and sleeping. So maybe you've gained some weight, so you're not in as good physical health, or maybe you've lost some weight, so you're, again, not in good physical health. So that would be the theory or hypothesis. So then you would compare the scores on the BDI to a physical health score. Now, again, in your textbook, they don't describe exactly how they calculated that, but you get the idea. Again, you would expect an opposing score. So that certainly was their hypothesis. So the lower the score in depression, the higher your physical health score. And you can see these clumped together right here, and this would be more of a negative correlation. Now, this is certainly not perfect because you can see here, there are dots all over the place. And I think it's because those two, unless you have defined it really well, I don't think they're always correlated. I think you can have significantly depressed people or individuals experiencing depression who maybe are part of the routine, like they work out still every day or they're still healthy physically. So I think that's why this is not a perfect example of that. Okay. We need to make sure that whenever you're looking at a specific scale, that the items are actually hanging together, that they are internally consistent, and that scores on a test retest are strong. Again, provided there's no intermediate intervention in between. So those are some examples of the items that were included in the appreciation and relationship scale. We've been talking about this a little bit over the last few weeks, you know, that you can measure appreciation by observing whether they say that they are appreciative or thankful of one another, or they could be taking this scale to assess, you know, how thankful they are with one another. So those are some examples. Now, notice that some of them say reverse scored item. And I think we've talked about this already, but in order to look at good internal consistency, you need to make sure that you are presenting items a few times to make sure that they are consistently responding in the same way, and that they don't have a bias towards answering in one direction or another. So I think we talked about that, like, do you usually put a B or a C for your response? Or do you just look at what's been done before? Like, what does that look like? So doing reverse scores allows us to make sure that the responses are consistent and reliable, and valid too, right? So notice here, at times I take my partner for granted. On an appreciation scale, you would want to reverse code that so that as you add them all up, if somebody said strongly disagree, that means they then rarely take their spouse or partner for granted. And you can see those that are not reverse coded are more directly linked. So I appreciate my partner, for instance, or I make sure my partner feels appreciated. So again, as part of this class, we are not designing scales, but it's important to understand when you use scales for research that they have built this in already. They have looked at how to make the test as strong as possible. All right. So what is, again, the relationship between both of those? We've talked about this already, but you cannot say that because a scale is reliable that it is valid. And you can't say that just a valid scale is also going to be reliable, right? Like, you really need both. It is possible a measure can be less valid than it's reliable, like a broken scale. Again, that's much higher reliability than validity, but it cannot be more valid than it's reliable. So claim to be measuring IQ when you don't have any internal reliability. That just doesn't lie together. And again, this is another important piece. Reliability is necessary, but it is not sufficient to establish validity. Okay. Again, you can have a very reliable score of measuring circumference of heads, but as to whether that relates to IQ, that's not a valid measure of it. It may be a reliable measure, but it's not valid. And again, the broken scale example and actual weight, that's another good one to show that it could be reliable, but then not valid. Okay. That is all I've got for you guys today. Questions about reliability and validity? Does it all make sense?
Yep.
Okay, thank you, Grace. All right, thank you, Cami, too. That's all I've got for you guys for today. This was wrapping up our lecture. Next week, remember that our article review number 2 is going to be happening, and then we'll have our follow-up lecture. And then getting ready, we'll do a little review by Friday on what you should be reviewing for the exam the following Tuesday. Sound good? Okie dokie. Let's work on that participation because I'm talking to a black box here for the most part. All right, you guys have a great rest of your day.
Thanks.
Professor.
Thank you.